We are going live. Okay, I think we are live now.
I'm monitoring YouTube, not yet.
It says 10 seconds live. I see 4 concurrent viewers. It's a lot. I think we'll wait for 1 more minute until people connect and we'll start. Oh, let me introduce my today guest, Vitaly Rybnikov, DevOps engineer from Tinkoff Bank.
SRE engineer, so.
Oh, sorry. Oh, my bad. SRE engineer from Tinkoff Bank. Okay, everyone can hear me and Vitaly well?
Yes, think.
Can you type plus in the chat, please? It will be very helpful. Oh, cool. Someone can hear us. It's good. Let's start. Today talk, we will start from introduction. And let's define the problem that we have. Many people have. Actually, I decided to make this talk to help my friends to bypass some restrictions of our government, which is very strange. For example, I can't read docs for my language of choice. And I can't open Telegram Messenger, and yeah, that just basically doesn't work.
But it's not main.
It's not.
Topic.
It's one of the problems that my friends have, and we will discuss how to bypass this problem. The simple solution is just basically SSH tunnel, and it really solves the problem. You just need to connect to any host somewhere where internet is much better than in your country, and it's very simple. For example, my AWS instance, and after that you can set up a proxy in your browser. To localhost and port the same. What?
Do you use Firefox?
For example, it can be any browser. And now you can open any site that you couldn't open before. It's simple solution, but it's not reliable solution, and it may not work for some cases. And also it's necessary to type this command many times. There is much more persistent and stable solution for this problem, and it is only part of our topic. The second part will be explaining what VPN is and what it is not. And what we are going to do today. Today we are going to make a setup. It will be my mobile phone. This one will be AWS instance. It will be DigitalOcean instance, and here will be Vitaly's phone. Let's create those instances first to make them initialized before we will go to practice. Can you show me? Thank you. And you can launch any of them. It doesn't mean it doesn't matter which version. Go to storage. Let's add some space in case we get out of space. My keyboard is broken. No? Hello?
Yeah.
It works. But oh, it's this customer.
Looks like your keyboard broken again.
Yeah, probably I didn't solder it good enough. This keyboard works well.
It's Dvorak.
No, it's just a keyboard. It's pity, but it's okay. Let's make a public security group to make it accessible from the internet, and let's launch it. And let's do the same for DigitalOcean.
The NixOS?
No, for DigitalOcean we will be using Ubuntu, and we will be using DigitalOcean instance for connecting to this network as a client, and also for demonstrating purpose, because in NixOS it will be much simpler setup. Okay, let's go to our picture, and we will connect all 4 peers in one network. And inside this network we will make another trick. We will make all our peers going to AWS instance, and AWS instance will be doing a NAT to send those packages to the internet, and it will change exit point for every other peer and using AWS instance as exit point to the internet. It's actually not the only application for VPN, but the one we will be using. Ooh.
Oh, it's like anonymous. We can.
No, not exactly. We will talk about it a little bit later. For our needs, we will need Nix installed. I already have it, but you can install it in one command. And after that, we will need a repository with few configuration files that we also be using for our today work. After that, we are going to WireGuard directory and running Nix shell. Nix shell will install all dependencies that will be necessary for today experimentations. And all those dependencies defined in shell Nix file. It's basically make, Nix deploy, WireGuard, and core encode utilities. That's all that we will need for today. If you have Nix, it just simply copying repository and running Nix shell inside it. And today, cases that we will cover will be following. We will combine few peers in one network, and we'll be able to communicate inside this network. And also for some of those peers, we will change exit point to the internet using one of those peers as a exit point and default gateway. Actually, it's much more applications for VPNs in the real world, but for our needs, we will do only 2 simple use cases. And why we will be using WireGuard instead of OpenVPN, IPsec, or something else? It's much simpler to configure WireGuard, and it's also simple in terms of implementation inside. Very small code base, good model, nothing fancy. You won't die when you're configuring it. And if you try to configure IPsec, for example, you probably know what am I talking about. WireGuard is also fast. It has low ping, lower than other VPN implementations, and it also has a good throughput. And it's secure. Basically, probably all VPN solutions, like modern VPN solutions, works good and has good security, but they don't have good defaults, and you can configure your VPN in the way you will be a victim of some attack. And why self-hosted instead of using some service like NordVPN or something else? Because those services can spy on you, can sell your data, can see which traffic going through their gateway, and so on. That is why I prefer a self-hosted solution and also recommend it to you. But be aware that if you make some errors, you can expose your data to someone. Be careful when you installing it. And few more reasons why WireGuard. It's energy efficient, and it's very silent and stealthy until you don't need, until you send something, it doesn't show any activity in the network. And it's stateless from user or administrative perspective. That means that you operate on it as on a simple Ethernet interface, and you don't need to care about established connection or something else. Yeah, it's very convenient for user. It's WireGuard designed for Linux, and it's implemented inside Linux kernel, but it works for other platforms. Implementation for Linux in kernel space allows to make it very efficient in comparison with different approaches that force packets to transfer from user space to kernel space and vice versa. And it also uses UDP protocol, which allows to make it more energy efficient, and also to go through some firewalls and strange setups that will break some VPN like L2TP or PPTP, in some cases, or OpenVPN.
And one question.
Sure.
Why NixOS?
Because NixOS will allow us to deploy the whole VPN setup using one command, and this command will be make deploy reboot. And I hope the instance already created. Let me check it. We can see that there is new instance here, and the public IP is following. I copied it, and I need to edit Makefile here, which is Makefile, and let's use Nana for one time. I hope I will be able to do it. And instead of remote host current address, which is typed here, you need to place your address that you get from AWS. And now save the file, exit. Type make SSH to check if you can connect to this instance. I already have SSH key installed on the remote instance. That is why it doesn't ask me any password, and I able to log in it. Nice. And now we will type make deploy reboot, and it will install, it will generate key pairs, and will install new operating system on the remote host, which already have NAT configured, WireGuard configured, and all other stuff in place. While it installing, we will go and check some theory. Do you have any questions, Vitaly?
Not yet, I think.
If someone has any questions, can type a message in the chat and I will try to answer them. A little bit of theory. It's pretty good WireGuard quick start tutorial, which on the official page of WireGuard, and I recommend to check it if you're new to WireGuard. And also it's a good talk from WireGuard after, which shows some details and explains some details of WireGuard protocol and WireGuard utilities. How it looks to work with WireGuard using basic approach. It's just creating new interface WG0, which has a type WireGuard. And after that, configuring IP address for it and setting few different settings using WG utility. It's in most cases private key and endpoint or listen port, or maybe something else like allowed IPs for the peers. And turning up the interface. That's all. That's all about configuring WireGuard peer. And how peers understanding that they can connect to each other. When you're configuring peers, you have to share public keys before configuring, and using public key cryptography, you are able to understand if person which sending a message to you is actual person is actual owner of this public key. For example, Bob has Alice public key, and when Alice sends a message, she can sign it with her private key, and Bob will be able to be sure that this message from Alice using Alice public key. And also, for example, Bob can encrypt the message using Alice public key and send encrypted message to the Alice, and only Alice can decrypt it because only Alice have access to private key. And when we have two peers that exchanged those theirs public keys and have their own private keys, they can interact with each other in a secure way. And when we finish with our step, is it make your presence in the network anonymous? No, it won't. VPN doesn't make you any anonymous than you right now. It just change your exit point, and it only changes it if it's configured inside this VPN using probably NAT or some other mechanism. That means VPN just connect few peers in one network, and sometimes it allows to use a different gateway than your current gateway using this VPN. There is no server or client in terms of WireGuard, in opposite to different protocols like L2TP or IPsec, and there's just peers, and peers connects to each other. But we will be calling a peer who listening for incoming connection. We will call it server, and who is trying to connect to this peer will be a client. But it's just our agreement. It's not reality. Every one of them is just peers. Any questions to the point?
I think we should practice and take a look in reality.
Yep, good. As you can see from the log, we installed our operating system on the remote AWS instance, and we can check. We can see that name of the server changed to WG server, and also we can type WG, and it's already listening 3 peers and our interface. That means that WireGuard already works on our remote server. Actually, we already can finish our presentation and go do some more interesting stuff, but we will connect to this server first. To connect to this server, we need to configure our clients. For example, I will configure my mobile phone to work with our AWS instance in one network. For that, we need to type command make clients /1.qr, and it will generate a QR code. Let's make it a little bigger, and let's make it proper color. And we need to see what is going on my screen. It is my screen, and I will scan from QR code and we'll go to type tunnel name VG. Okay, we added our configuration to the mobile phone, and let's check that this configuration works. First of all,
Can you scan your QR code too?
one second.
Okay.
Let's try to open LinkedIn. It doesn't work, as you can see. And let's try to open ifconfig. It works and it shows some IP address. And now we're going to WireGuard client and enable VPN. Now we can see that our IP address changed and remote host has some relation to AWS. And LinkedIn also works. Nice. Cool. It works, and let's see what happens on our server. On our server, we can see that it says peer with this public key connected to us with this IP address from this port 26 seconds ago. Now we will do a very interesting thing. We will disable our Wi-Fi for a while, and we'll enable our mobile network. And now, if we update our WG, we can see that nothing changed because we didn't do any actions. But if we, for example, open LinkedIn and check, we can see that port number and IP address changed. Comparing to previous one. Yeah, previous one was this one. Yep. And new one is this one. It's called roaming, when you can change your networks without disconnecting from the your virtual private network. It's pretty cool feature. A similar feature you can find in Mosh. MOSH. It's SSH client which works using UDP protocol. And let's check that our connection is stable and have pretty good quality. I have speed test probably on my phone. And let's run it.
It looks like it's just reconnected during your switch your network, isn't it?
Actually, it's not reconnected because there is no connection at all. There is two peers which communicate with each other using UDP protocol, and UDP protocol don't have connections. But there is internal mechanism inside WireGuard called sessions, and sessions is something that not visible for user and something that happens inside WireGuard. And actually it for you it's just the same as you're always connected to VPN, even if you don't have network. For now we see very low speed. It because I connected using my 2G network, and we connect back with Wi-Fi and connect, go.
Do you have only 2G network?
No, I
4G now?
I have 4G network, but it's disabled for now. And now we can see that ping is very low and limit and speed limit is pretty big. It's actually something around my real speed using my Wi-Fi. Okay, let's go back to our presentation. For example, we want to connect one more person to our network, and it will be Vitaly's phone. Oh, I wanted to talk about routing a little. Okay, what makes it possible to access internet using our AWS instance? Because you probably remember in this picture we have just few peers that connected in one network, but how we did that one of the peers become a gateway for other peers. It's done using routing, and we can see which routes on our server, and we can see that two routes to our IP addresses to our clients will be using interface WG0. And if we see to my mobile phone routes, one second, let me open terminal here. Oh, and let's type IP route something like show table all scope link. Correct. Oh, it will be very hard. I will type it on my laptop keyboard. Show table all scope link. Yeah, we can see that default route here is dev-tune0, which is actually WireGuard interface, but it's called tune here. That means that all traffic that going to the any IP address, if there is no specific route for this address, the default route will be used, and all this traffic will go to tune0 interface and will go inside VPN. And on our server, we already configured network address translation. And let's see at actual configuration file of our server. It will be called WireGuard default NixOS, and it already contains few lines which configuring our network address translation. And this IP tables is a basic Linux firewall, says that everything that comes from this subnet, from any IP which starts with this prefix, have to go to S0 interface and get nutted. Cool. And also we see that we have 3 more peers, and for example, if we want to add one more peer here, we just copy already existing peer, insert it, update number to 4, IP address to 4, and also update Makefile. Oops. And here for WireGuard out, we add one more dependency. We need one more public key generated. And when we type make deploy, another key pair will be generated for our new 4th peer, and new operating system will be built here, and this operating system will be copied to remote server and installed. Actually, you see, it's pretty fast process because there's already a lot of stuff on our remote instance, Amazon instance, which already contains almost all necessary files, and only difference between previous version of operating system and new version of operating system will be copied. That is why if we SSH back to our AWS instance, we will see that now there's 4 peers and new one is here. Okay, let's make Vitaly connected to our network too. Are you ready?
Yeah. I have installed WireGuard up.
I have
Will it work without inversing colors or not?
It won't work, probably. Oh, I don't want to make your face hidden with with this core code. You probably
VG0 create enable. Oh, let me check my.
Let's go back to our server. Oh, I see you, bro.
Yeah, LinkedIn working. Oh, I go chatting.
And I also showing your IP address that everyone now can hack you. Sorry.
Do I am I have public IP address, or am I knotted behind my?
I don't actually know. It doesn't say anything about it. It may be both cases.
My Play Market doesn't work.
Okay, we already talked about that we are using NAT, but what is actually NAT? NAT stands for Network Address Translation, and it's like it works, the network works a similar way as your post in your country, but maybe not so bad, but the same way in terms of addresses. It has destination and source addresses, and when you connected to the internet through gateway, sometimes you don't get a public IP. You're using the IP address of your gateway. That means that your internal IP address won't be visible in the internet. And when you establish connection, you send the package to some server, and your gateway change the source address from yours address, from this address, to address of the gateway, public address of gateway. And when remote server will be responding, it will be responding to the gateway, not to you. But gateway knows that there was a connection to remote server and it's changed IP address, and it will change in respond IP address from itself to your IP address, and you will get this package. It's called NAT. And what we've done on our server on AWS instance is absolutely the same thing. Everyone inside our network using this feature to access the internet through this Amazon instance. I didn't talk about configuration a lot, but if you open it, it's pretty simple. It just says which package to install, which kernel modules to install, and which network configuration do we need, and something about WireGuard configuration. And in our Makefile, we have few targets, which is basically just simplifies typing in command line. You can type it yourself, but it's much more handy to type make something and not to type those commands. Those commands just builds your operating system and deploys it to remote host. More about syntax you can find, make syntax you can find in the network. It's pretty popular tool among C developers and also other developers. Okay, and also a few words about the Makefile. You have special targets called keys and ID of your peer and brief key or public key. And it generates key if it doesn't exist, but if it exists, it's placed in keys directory, and you can see all the keys that was generated for this setup. You have to keep them private on some encrypted storage. And also this target called clients slash some ID, for example 3.conf, which generates configuration file, and you can read this configuration file from clients 3.conf, and it's a WireGuard configuration. It's a whole WireGuard configuration, in our case for client with ID 3. What is written here? It's your private key, your address. Actually, address and DNS is extended options, which will work only if you use some utilities like WG Quick or something like that. It's not options for WireGuard itself, but for wrapper around WireGuard. Public key of the peer, it's public key of our AWS instance, and it's public IP and port. And here we say that any traffic which arrives from the peer with this public key can be from any IP address. Yep, it's basically the whole configuration that we have for the whole peer. And let's deploy it to our Ubuntu server on DigitalOcean. We updated configuration, already deployed it, and already made a configuration for the third peer. And now we will we'll check the address of our instance on DigitalOcean. And let's type this address to variable ubu. Let's copy our configuration to this host. Let's connect to this host, and let's see that configuration is here in our home directory, the same configuration which we just copied. Let's change password. It will be necessary in the future. Oops, one more time. Good. And let's update our package list and install WireGuard, ResolveConf and Python 3. You saw that when we installed the whole VPN server on NixOS, it took only one command, and here we type a lot of commands, much more harder, and much less reproducible in the same way.
It's because you don't using Ansible, it's just one command.
Cool. Actually, yes, you can use Ansible to get something similar to what NixOS do, but the difference will be that Ansible try to make your system and put it in some state, but NixOS really creates new system and just switch to new system. That means that Ansible, if you applied some configuration from Ansible, but somewhere between you modified your system using some commands, when you will switch using Ansible, you can get unexpected result and undefined behavior, depending on which commands you made before you run this Ansible script. That is why in Ansible people using a golden image, as an image from which they are creating new state of the peer using Ansible script. But in NixOS, you can take any NixOS peer and switch it to some desired state without worrying about what was done to this peer before. And you can read a lot of information on official site on NixOS about Nix and both NixOS. Nix is a package manager, and NixOS is operating system based on this package manager. Yep, we installed all our dependencies. Let's copy our configuration file to WireGuard directory, and let's create a systemd unit for WireGuard. And now we can find systemctl status quick. We can find our systemd unit and see the process. It's currently inactive, but when we will reboot server, it will be up and running, and one more peer will be in our network. Let's reboot our server, or we can just start the systemd unit, but let's reboot it to check if it will up automatically after reboot. We won't be able to connect it using our SSH, because any traffic will go through VPN tunnel. That is why we will need to connect to it using console. And that is why I changed root password to be able to type it. And now,
Could you repeat, why do we need to use console and not SSH?
Because if you see at IP route, we will see that this default route says that every package which not matched with any other route goes through WG0 interface. And if we try to connect to root at Ubuntu, it won't connect, because it tries to answer using WG interface, and it's not what we are expecting.
So we should connect via internal IP address only.
Yeah, but the problem is that I am not the part of this network. My desktop is not part, but your desktop is, your mobile phone is a part of the setup, and my mobile phone also. Actually, let's try to connect from my mobile phone. I don't know if I have SSH here. Let's check it. SSH.
Telnet or curl.
Install SSH. Oh, don't sleep, please. Apt install open SSH.
Wow.
SSH root at, do you remember the IP address?
But you need the internal IP address.
Oh, sure. It's true. It will be, boom. No, it doesn't work. It's something wrong with SSH on my phone. But we can do, oh, that's a trick. We have our remote host, cat Makefile. Oh, it's easier to watch here. We have public IP, and we can SSH to this public IP. Actually, I could type make SSH. Make SSH. And from here, we can see that there's 3 peers connected to the network, and we can SSH to any of them, but we will go to our third one. Boom. Permission denied.
Yep.
Because it doesn't allow to connect using password from remote host. You can only log in using TTI. That is why we will do a trick. We will forward our SSH agent, which contains my SSH key, and we'll try to connect to it one more time. Bam! And we're here. And now we can launch Python 3 HTTP.
But why you can connect to your OS instance via public IP and you can't connect to DigitalOcean with a public IP?
It's a good question. Let's see which configuration. On our AWS instance. On our AWS instance, the configuration listens the port and has some private key and few peers. And as you can see, each peer allows to have only one IP address. That means only items that should go to those IP will be routed to those IPs, but every other package will go to our basic routing table. And if we check our routing table, we will see that we have special rules for those 4 IP addresses, and there is no default gateway in this routing table. And we can see that our default gateway will be this IP address, which is basically Amazon gateway, and using Ethernet 0 interface. That means that all the traffic from this AWS instance going to the Amazon gateway instead of our WireGuard peer. But every client has different routing table, and if we connect to our host, IP route show table all, we can see that it has default route using WG0 interface, and all packages going through this interface. Yep, and let's do one more magic thing. Python 3 http.server port 800. Now we started simple HTTP server on our Ubuntu host, and let's open our mobile phone. Do we have curl here? Install curl.
You can use browser.
Yeah, actually yes, you're right. And I can go to 10.hoop. Boom, and I can see
you hacked the server.
Any file on the server. Oh, I can't open it. Okay, let's do it using curl. Curl will show the content.
I just copied SSH key from the server.
Nice. For some reason it doesn't install curl. Okay, let's do in a different way. cd work, cd configs, WireGuard and Nix shell make SSH, and from here we will we'll do get request, and we'll see the content of bash rc. Yep, and it's basically the content of bash rc of our DigitalOcean peer, and we can see our access log here. You copied only authorized keys. It's only public keys listed here.
Okay.
You didn't hack it. Cool. We set up our network. We checked that every peer connected with each other, and some of those peers can access internet using one of the peers as a gateway. And this is what people trying to get using VPN in basic day life. But there is much more application of VPN and WireGuard and other network stuff that we touched slightly here. Even our setup can be improved in many different ways. For example, if we have a list of blocked sites, we can make a conditional routing which route only traffic which addressed to blocked resources using VPN tunnel, and it will reduce the amount of traffic going through your instance. Also, you can use network namespaces to make some magic. For example, to route only traffic from your Docker containers using VPN or something similar. And we can make a simple admin interface for WG server, which will be creating client configurations and update server configuration automatically to make it easier to connect to your server. We can use DNS server inside our VPN network to make DNS requests more secure. And we can do a lot of other interesting stuff. Only our imagination will restrict us. And I hope it's all for today. Any questions?
I have a question about configuration.
Mm-hmm.
How can I specify? What if I don't want to pass all traffic through the VPN, but only peers and services inside VPN?
Cool question. First of all, the simplest solution for your question, it's update our configuration to following form. Let's see how our configuration looks right now. Clients 3.conf. It says that allowed IPs will be 000 blah blah blah, and here you can put 10.100.0.0/24. It will make automatically all traffic to this network go through your VPN tunnel, but every other traffic will go on his own. And it is the simplest solution. And you remember that I showed that there is a default route here created. And if we look at systemd log of our VG Quick, we will see that it's automatically issued a lot of commands. A few of them you can see here. It's actually creating of your route automatically, and actually routing and other stuff isn't a responsibility of WireGuard. WireGuard doesn't care about it. WG Quick is just a bash script wrapping WG and few commands, which is routing and some rules for firewall and so on. That means if you configuring your WireGuard setup using WG Quick, the simplest way is changing allowed IPs variable. But if you don't use WG Quick and configure it using similar commands, you can create any routes that you want and route your traffic as you want.
Okay. And one more question about client configuration. Could you show it?
Yep, sure. Oh, we are too deep. Right here.
What is the meaning of public key here? Is it client public key?
It is a public key of our peer, and this peer for this client will be a server. This configuration says that I'm a peer who have private key, this private key and this address, and I will be communicating with this peer which have this public key and this endpoint. And it's public key of the server, or in a real world it's just a peer, just another peer that we are connecting to.
Okay, I see.
Yep. Any other questions? Nope.
No.
Cool. I'm glad to see everyone joining here. I'm glad to have so nice discussion with Vitaly about capabilities of WireGuard, VPN, and all other stuff, and NixOS also. Have a nice day, have a nice evening, and have a good mood. We'll see you in a while. Bye.
Bye.